Hi, everybody, and welcome to second semester. Yeah, I'm Mr. Folly, and this is 6.1. So let's hop right into it. You need a calculator and your periodic table for this happy-go-lucky little outing. So molar mass and mass to mole conversions is what we're going to look at, okay? So first of all, we need to know that atoms are so small, we need to think of them as groups. We don't buy drops of gasoline. We buy and buy 12 gallons, except for the hippie Tesla drivers. Okay. I'm a little jealous. I wish I had a Tesla, but I'm all right with my gas burning Chrysler. We don't buy 755 cubes of ice at the gas station. We buy a bag of ice at the gas station. Note these are easy to handle numbers, typically between 1 and 999. Paper is small. How many sheets in a ream of paper? Hey, that's 500. Bottle rockets are small and sold by the gross. Oh man, I meant to set that up, but I didn't. So I should have a little video. If you click on there at tinyurl.com/bottlerocky, you'll see 10,000 bottle rockets shot all at once. Atoms are the smallest yet. Molecules of compounds are the same. So molecules of compounds are the same. So notice they're so small it doesn't really matter. They're grouped in moles. Smaller things have bigger groups. Piece of paper is smaller, come in the 500. Okay, ice cubes are bigger. There's 755 in a bag. 1 mole is 6.02 E23. Okay, maybe you're a little more used to seeing this as 6.02 times 10 to the 23rd. And what that means is that it counts your decimal places here. Okay, so there's a couple of these. I'm going to admit these are star problems. These are just to give us the right idea. How many atoms are in 2 moles of Na? To do that, let me show you the new way that we do our conversions. Whoops, you spell moles MOL instead of MAL. 2 moles of Na. And what we're going to do is these things have to be equal to each other, okay? So 1 mole of Na equals 6.02 E23 atoms of Na, okay? And then notice how moles of Na cancel, and my final unit is atoms of Na. So I put this in my calculator, and I get 1.204 E24 atoms of Na. Okay, the way you get the E button on your calculator is you type 6.02 second, there's a second button, comma. And that comma is right above the number 7, okay? What if I have 2.5 moles of helium? All right, so I'm going to zoom in a little bit, and I'm going to make my pen a little skinnier. And if I have 2.50 moles of helium, same thing. I want to cancel moles of helium, so I put moles of helium on the bottom. Remember, diagonal things will cancel. And I'm going to put 6.02 E23 atoms of helium. So notice it doesn't matter what it is. The number of atoms, as long as it's on the periodic table, is going to be 6.02 for 1. Kind of like for a dozen, it's 12, whether it's a dozen donuts or a dozen eggs or whatever it is that goes through it. So calculator time, 6.02 second, comma, 23 times 2.5. 1.51 E24, atoms of helium. Now I'm going to be honest with you. The atom calculation you're not going to have to do. So boo, but that's the truth. Now you do have to do this on the test. Molar mass. Mass of 1 mole of a substance. I know that's a cheesy definition. What's a molar mass? The mass of 1 mole of a substance. Atoms and moles are still pretty worthless units, right? If I told you give me 50 atoms of something or 3.2 moles of something, we need to get grams. So we need to get out our periodic table. So let's go ahead and do that. So here's a little snippet of the periodic table, okay? To find the molar mass, we're just going to add up the parts in the unit grams. Carbon is 12.01, oxygen is 16, 12.01 plus 16 times 2, and the units are grams per mole.
Oh, this is a lot. How much are we need?
F2. See how this there 19? 2 times 19 is 38.00 grams per mole. That grams per mole means 32 grams in 1 mole. Okay, this one's a little bit harder. Aluminum is 26 0.98. Aluminum. Nitrogen. So I have 3 nitrogens. 3 times 14.01 plus 3 times 3 is 9. 9 times 16. 26.98 plus quantity 3 times 14.01 close quantity plus quantity 9 times 16 close quantity. Enter 249.01 grams per mole. Notice we want 2 decimal places. Okay? All right. Converting grams to moles and moles to grams. So, conversions are set up to cancel units. So, if I have 2 sevenths times 7 thirds, and notice how my diagonal things cancel, and my answer is 2 thirds. If I have 3 over 3, I can cancel those things. And note if we multiply by 3 over 3, it's the same thing as multiplying by 1. It's the same thing as kissing your sister. Nothing happens. You get the exact same thing. So let's take a look and see what this looks like here. So if I'm going to convert 3.50 grams of NO2 to moles, I write down my given, boom. I'm always going to put my bottom unit on the bottom. So cancel the bottom unit by cancel the unit by putting on the bottom. Okay. And then on top, what I want to go into. So again, cancel what you want to cancel goes on the bottom. What you want goes on top. Remember, anything on the bottom equals divide. Top equals times. I know that's very cheesy, but don't you mess that up. 3.5 divided by 46.01 is 0.0761 moles of NO2. All right, so go to the periodic table for the mass of the point. So what I did, I went to the periodic table for NO2. Right? So when I wanted grams, I go, little g stands for grams, and little g stands for go to the periodic table. All right, so let's do this. Okay, you need your periodic table. So I have a lot of these memorized. You don't need to memorize molar masses, but I have a lot of these memorized, so you want to make sure that you're with me on this, okay? So 0.550 grams of H2O times dividing bar. I want to go to moles. I hate you grams of water. In order to cancel a unit that's on the top, I put it on the bottom. I want to go into moles. The number I'm going to have is 1 mole. The number 1 is going to go with moles all the time, not mole. H2O. I go to the periodic table. Hydrogen is 2.02 for 2 of them, right? 1.01. And then oxygen, look at the periodic table, is 16. Add those up and I get 18.02. 0.55 divided by 18.02 is 0.0305 moles of H2O. Okay, so 23 grams of barium nitrate to moles. Meanness, how many O's? Again, this is 6, not 5, right? Remember, you multiply those. So I'm going to start with 23.0 grams of BaNO3 taken twice. Now, what goes in the bottom? Whatever your given unit is. I'm given grams of barium nitrate. So I'm going to put grams of barium nitrate on the bottom. Little g stands for grams, and little g stands for go to the periodic table. And I'm going to go into moles. So 1 mole of barium nitrate. All right. So go to the periodic table. Barium is 137.33 plus 2 times nitrogen. Nitrogen's 14.01 plus 6. 2 times 3, don't add, times 16. So let's see, 137.33 plus quantity 2 times 14.01, close quantity, plus quantity 6 times 16, close quantity, 261.35. And let's see what we got here. 23. And notice how grams of barium nitrate cancel. Just like when I had up here, my 7s canceled. right? So 23 divided by 261.35, and I got 0.0880 moles of barium nitrate. I want to point out, those start with grams. Now we're going to start with moles, okay? So 10.50 moles of liquor times dividing bar. Given unit goes in the bottom. Moles of liquor goes in the bottom. Remember, the number that goes with moles is 1. And I'm going to go into grams. Little g stands for grams, and little g stands for go to the periodic table. Lithium is 6.93. Chlorine is 35.45. You should be able to see that in your periodic table pretty easily. And that is 42.38. So 10.5 times second answer is 444.99. All right. Whoops, I didn't mean to. 2.55 moles of CH4 to grams. So 2.55 moles of CH4. Again, whatever's on top, I want to cancel it. 1 mole of CH4. The number 1 is going to always go with moles, right? Grams of CH4. Little g stands for grams, and little g stands for go to the periodic table. Carbon is 12.01. Hydrogen is 4 times 1.01. And together that is 16.05. So 2.55 times 16.05 is 40.93. And I think that's it. It is. To that, I will say, toodles.